So Kate, it's a pleasure to be here today. I know a lot of our audience is grappling with the uses of AI, machine learning, and the journey that we're all on, right? And we see a lot of things in the press around the challenges from AI. We see a lot of pressure from our boards of directors and our CEOs around adoption of these technologies. And I'm excited to talk about that with you around some of the challenges that we see. But before we get there, I think it would really help to really talk a little bit about the journey that you've had in AI, because I think many of us that have been in this for some time have worked in this area for many, many years and had unique experiences that allow us to have a perspective on where we are today and a lot of the excitement and enthusiasm around AI. So could you tell everyone a little bit more about your journey?
Sure, thank you, Scott. And first of all, thank you all for inviting me to come and talk with you today. This is such an important gathering of people who are really at the forefront of thinking about data and how it can actually change the world. For me, I really got started in this space about 14 years ago when I started doing large-scale data studies of what happens in natural disasters. And at this point, I'm in Australia. I have my own research institute. We're right by the beach. I can go surfing every day. Everything's great. And then suddenly we get hit with a very serious flood. And this was in Queensland at the time. And we had a floodplain the size of France. I mean, this was an enormous disaster. And one of the things that was really emerging at that time was how could we start looking at data patterns to understand what's happening in natural disasters? So really early stage social media studies. And what was interesting was that, first of all, we're like, this is great. We can actually see how people are reacting in real time. You could think about sending resources to where you're seeing the most activity. But the more I dug into it, the more I realized that, well, social media patterns are not spread evenly. We know that particularly then, we saw far more young people and far more people in urban centers using these sorts of tools. So we realized that we just didn't really have a representative data set about what was going on. And that was my first clue that as we started moving into machine learning, we had to be a lot more forensic about what was happening with data. And then about almost 9 years ago now, Microsoft Research called me up. And at this time, they were starting really big machine learning labs. And they said, look, we're interested in having social scientists come and build these systems with us to think about what the broader implications are of what we're doing here. And so I was really lucky. I had a ringside seat at one of the sort of major AI companies in the world as they were spinning up their biggest machine learning labs. And what I learned from that has been extremely profound. It put me in this position at the table to see how powerful these tools can be, but also why we have to be so careful, why they actually represent, in some ways, tools that we don't yet have real safety guidelines for. And in so many ways, we're kind of figuring it out as we go. And so that's really what I've dedicated my research to, is to figure out how we can find those problems, detect them, and address them. But let me ask, Scott, because I'm really curious, you've been doing this for a long time too. Like, what brought you into this field?
So yeah, it's interesting. I joined HNC FICO 20 years ago, but prior to that, I was at Los Alamos National Laboratory. And I was a theoretical physicist with a very heavy bent on computational science. And my work there was really focused around the limitations of prediction. I was very much focused around chaos theory, and I was very much focused around turbulence, and I was focused around how accurately can we simulate phenomenon, right? And there's a theory around shadowing, which is called shadowing theory, which basically says that there's certain problems that are completely unpredictable. Mm-hmm. And so I was really enjoying that work. I became aware of two things. I became aware of San Diego with beautiful beaches also, yeah, okay. And but also HNC software, which was solving some of the some of the really, really difficult problems around human behavior in the guise of trying to predict fraud back in the late 90s and early 90s. And so at that point, I said, well, that's a much more interesting problem to work on than some of the simulations. And then I started here at HNC and then later FICO, focusing on applying machine learning to solve these business problems, but all around figuring out how to make these predictions and to kind of improve business outcome.
And that makes so much sense to me, because in some ways, starting from that perspective, as really in the world of physics, we know about uncertainty. We think about how things are never necessarily what they seem, and we have to look much deeper than just original pattern making. And I think that's really going to serve us well in what's really happening right now with the spread of machine learning to almost every domain that we can think of.
Absolutely. And, and maybe that brings us to the next point, because both of us have this sort of perspective around some of the challenges with machine learning. But one of the things that's been a little bit exciting, but also really frustrating, is you open up the web browser and you see another article about AI and machine learning. And this is the transformation period for many of us. But what I've been talking about is the hype cycle, right? Because I see so much excitement and so many different companies trying to apply machine learning. And I do think there's a tremendous opportunity for transformation, and we see that in many parts of the business today. But what do you see in terms of some of the greatest opportunities, but more importantly, maybe some of the largest dangers that we may encounter as we start this journey around using AI and machine learning at scale?
Well, I mean, if I'm honest, I think we're at a pivotal point in history. We've discovered a very general purpose tool in machine learning. And really, I mean, we've been developing in some ways neural nets since the 1960s. But it really wasn't until around 2005, 2006 that we started to see the ability to scrape huge amounts of data off the internet and to train systems that could do large-scale statistical pattern recognition. And this was pretty extraordinary. You needed to have lots of data. You needed to have huge planetary scale compute. And then you needed to have good algorithms. So we got to this point where suddenly we could start to use machine learning in all sorts of really sensitive social institutions: criminal justice, education, healthcare, hiring, all of these domains where previously humans had done most of the work. Suddenly we could say, you could actually start to do some really interesting data analytics and prediction based on the patterns of data that we have. And that sounds great. And everybody says, yeah, fantastic, we're doing machine learning, well done. Until you start opening the hood and looking at the data that's in there. So what we've seen in just the last 5 years in terms of the stories about bias in artificial intelligence has been extraordinary. I first started giving talks about bias in AI probably about 7 years ago, and it was like a heresy. It was like, you can't be serious. With more data, we have greater accuracy. If we can't have bias in large data, it's like, yes, we can. And what have we seen since then? We've seen some really terrifying stories. For example, you might have read about Amazon, no slouch when it comes to AI and large-scale data. They decided to build a CV scanning system so that for the thousands and thousands of people who want to work at Amazon, they would send in their CVs, and the machine learning system would tell them who to interview. Sounded like a great idea, until 2 years later, they realized that that system had been almost always recommending men over women. Even if you said the word woman on your CV, it would get bounced to the bottom of the pile. So they were like, what's going on? This is terrible. Until, of course, they started looking at the data. They'd trained the model purely on their most successful applicants. And guess what? 90% of their technical workforce are male. So what do you know? You just trained an AI model to just always interview more guys. So this happens all the time. What we've seen just in the last few years have been large-scale ad systems on Facebook that have both race, age, and gender discrimination. We've seen it at Google. We've seen it at Microsoft. And Microsoft, of course, had the famous Tay bot, which within 24 hours had turned into an extremely racist bot. So basically what we're learning is that these systems are much more complex than we think, but we really need to look at that data layer to fully understand them.
Yeah, I mean, it's a great point, right? I mean, the models are a reflection of the data. Yep. And if the data is biased, or if the way we form that data is really a challenge, right, then the model is simply going to represent the bias or the way we selected that data in the first place, right? And bias is a tremendously important part of our business to try to make sure that we identify, we correct for, we understand that's in there. And one of the big challenges has been around the fact that these, as you mentioned, these models tended to be, black box. And, one of my experiences thinking back about the last 20 years has been that most of our clients 20 years ago would ask us very intelligent questions about, how did you build it? What was the data? Can you explain more about the features? Can you tell me what's inside this model? Today, we barely get a question like that, right? And we've almost gotten to that point, to the point you made, where people accept that it's a machine learning model and it's used by reputable companies, it must just work, right? And it simply doesn't, right? In terms of when you build a model, you need to look at all those sort of aspects, which brings us to this sort of philosophy that I have, which is explainable first and then predictive second, right? We have to focus on that because very often explainability either doesn't come up or it's a secondary phenomenon that we think about. But with that, I think the other thing that's really interesting is, when we look at the data problem is around data and privacy. Right? We're seeing much, much more of this, and we have a global audience here. Many of you have data protection regulations, GDPR being one that we track very, very closely, right, which talks about your right to have the data excluded from models. It talks about the right of a consumer to have a decision, particularly an automated one made through a profiling model or a machine learning model, to be explained to that consumer. What's your thoughts about data and privacy, and what are the implications to AI?
Yeah, I mean, this is a really tough one because if you look at both explainability and privacy, if I had to give us, a score out of 10 in terms of how we're doing on that in terms of deep learning, probably going to give us a 2. And really, that's because in the end, deep learning, the way it's currently constructed, even engineers who are making the absolute state-of-the-art deep learning models cannot tell you how they get to the answers that they get. And there's a lot of reasons, technically, and I won't bore you about why. But what we need to know right now is that essentially explainable systems are, at the moment, getting trounced by deep learning systems, which are faster, can get you different sorts of insights more quickly. And even though that can be super appealing, you can say, oh, let's do deep learning. It's almost impossible to wind back the clock and say exactly how did we get these results. And I know this is something that you've thought a lot about, Scott.
Yeah.
But if we then turn to the privacy question, we have a completely different issue. So right now, if you wanted to train, say, an AI system to detect the differences between pictures of cats and pictures of dogs, what would you do? Well, what most people do these days is that you would download hundreds of thousands of images of cats and dogs from the internet. So you'd be training your model to detect the differences between, okay, this looks like a cat. When I get a new image, this looks like a dog. Now, what we've done is that we've done the same with people. We have downloaded hundreds of thousands, in fact, some cases, millions of pictures from people's family albums, like their Flickr sets, from Google image search. I mean, basically, all of the images on the internet have become fair game. And for 10 years, that was just standard practice. And right now, I think people are asking really important questions and saying, well, why is this okay? This actually raises a whole lot of problems when, again, you start to look at how what's happened to those images when they've been used in, say, machine vision systems, is that they've also been labeled. So we recently did a study looking at ImageNet, which is created by Fei Li, a team I deeply respect, and they've had this online for 10 years. Not only had they scraped 14 million images of people for this set, but they'd put them into categories. And some of these categories made sense. You've got categories for like scuba diver, cheerleader, Boy Scout. But then you have categories for really strange non-visual categories like debtor or criminal or bad person. And then you have some really problematic labels for things like alcoholic, drug user, kleptomaniac. And these are just images of people taken off the internet. Like there's one image of a guy, I always just feel so sorry for this guy. He's just holding a beer and he's gone skiing and he's in this giant sort of data file of alcoholics. And it's just because this poor guy's holding a beer. And again, it's like, how have we made these really kind of quick decisions around scraping and classifying data that can come back to haunt us? So what's happened with GDPR is that people are saying, you really have to think harder about this. And right now, we're starting to see in the US 2 very strong pieces of privacy legislation. One is called BIPA, which is a biometric privacy law in Illinois, which is asking really important questions around putting frameworks around things like facial recognition. And of course, California just passed the strongest privacy law in the country. So we're having a real sea change where people are starting to say, we need to be a lot more careful with that data. We need to think about the human costs of that data. And then we need to think about how it might have impacts in the long term that we need to think about now.
I absolutely agree, and it's scary, right, when you don't have an understanding of the data that's out there about yourself, and when you start to look at how it's used in, let's say, a deep learning algorithm, and the fact that these correlations or tags that someone's made arbitrarily about some of your data, right, will later on be used for many, many different types of decisions, right, and I think this is one of the biggest challenges, and from my opinion, the data regulation and privacy coupled with AI and responsibility and explainability are going to have to come together because one's going to be affecting the other one. But the biggest challenge that I see today with things like philosophies around data is the concept of big data, which was a very big thing. It continues to be a big thing today. But the concept was we'll just throw more data at it and we'll find more relationships, right?
Yep.
But then you find these relationships and they say, well, okay, so for credit risk, the fact that my battery is 40% charged means that I'm a high delinquency versus if I kept it at 80% charged, right? And you can ask whether that's the right sort of feature and is that a legitimate feature? Is it a fair feature, right? And these are really, really difficult questions. Now, if we had an architecture, we can expose that, and we can look at the data, we can look at the relationships, and we can rationalize it. That's one thing, right? But if we just assume that we're going to be able to go and more data is going to solve the problem, and we simply won't understand how decisions get made, that's where there's a tremendous problem.
That's right. And that's actually what keeps me up at night, is that I think there was this gold rush period where everyone was like, let's just build the systems and use whatever data is available, and never actually look at what was in there and how it was tagged. I mean, I spent last year looking at something of the order of 450 benchmark training sets in AI. And what was incredibly just shocking to me was even in many cases, the engineers who built these things had not looked at the data inside it.
Yeah.
And so what that means is you really don't know what the level of quality is that you're getting with systems like this. And then you start to have these large-scale disasters, the AI disasters that we've had. And we've got a slide up here, which is just all of the sorts of stories about not just bias and discrimination and systems failing, but people pushing back. What you're really starting to see now, and this is really relevant for your customers, is that people are saying, this is not okay. We actually want to have stronger privacy. We want to have stronger guarantees that this system is actually going to perform well for everybody. Yep. And again, because we're seeing huge disparities around race, gender, geolocation, we actually have to start thinking much more carefully around fairness, accountability, and transparency when it comes to machine learning.
Absolutely. So let's talk more about that, on the topic of explainability or ethics, right, around ethical AI. It's a broad topic, right? So it ranges from explainable models or explainability, accountability, even concepts of liability. Maybe we focus first on explainable AI. It's a really big topic for us, right, given the fact that we have to explain the models that we have out there today, right? I'm actually proposing for FICO that we have different types of model architectures altogether, right? For those that know me, they know that I'm not a big deep learning fan, right? Because I'm responsible for explaining these models,
it's your
right?
job.
Yeah, and make sure they come out properly, right? And so looking at brand new algorithms that expose the relationships in these models, right? But there's a whole class of algorithms out there that you apply an explainable AI algorithm on top of the model you can't explain, and you have to feel comfortable with that or not feel comfortable with that. So what's your vantage point? I mean, I have a particular vantage point because of the types of models that we build for our customers and the fact that we have to make sure they're high quality and we understand how they're going to perform and our customers do, right, for their customers' sake. But what's your view in terms of where we are from this concept of explainability as one of the assets or pieces of this ethical AI topic?
Well, first of all, can I just say thank you for doing that hard checking and saying, oh, just because deep learning is the latest cool thing doesn't mean we should just apply it everywhere. But let me tell you a story from a colleague of mine who has been looking at this question in health data. So health data, definitely something that we want to make sure we're getting right. And what he did is he trained two models. One was what's called an interpretable model, so you can see how it came to a decision. And one was a deep learning model. And what he did is he trained it on pneumonia patient data. So if you go into hospital and you've got pneumonia, how do they decide if they're going to triage you into emergency care? And basically, they took the same data, put it into the two models, and waited to see what they got. What was interesting was that the deep learning model was actually really very sensitive to looking at particular changes in a person's, like just general kind of biometric health signatures. So it was good at detecting issues that could be a problem that mean you should get up the chart into emergency. But it had one critical mistake, which was that it would recommend that every person who had asthma just be let out of the hospital. Just send them home. If you've got pneumonia and you've got asthma, don't worry about it. Just go and take an aspirin and have a lie down. It's like, what? If you have asthma, you're exactly the person, if you have pneumonia, that we should be seeing an absolutely emergency care immediately. So we would have had no idea why it was recommending this if he didn't also have the interpretable model, which by looking at the data, it showed, oh, wait, what happens? Every single person who's had asthma, who's come in with pneumonia, has received immediately the most top level of care, and they're the people who've actually gotten better the most quickly. And they were less likely to sort of have to come back time and time again, which is very frequent with pneumonia. So they looked like the group of patients who were generally having the best outcomes. Fantastic, right? So without that interpretable model, this would have been a real problem. You would have had a deep learning model saying, okay, this high-risk group are actually okay. So this is one example of something that we see happening time and time again. And it's not just in the case of like academics studying this. IBM Watson, which you've probably heard of, it's one of the sort of most well-known big-scale AI systems, was recently just discovered to be making unsafe and dangerous cancer recommendations. And we only know this because of a whistleblower inside the company actually leaked the data to show it. So even at the absolute top end of town, people are having these problems. So in some ways, I sort of think about sort of big data hubris. We used to think, oh, big data, we've got it figured out. But right now, I feel like we need AI kind of humility. We need to be like, we're at the beginning of something really big, but if we get it wrong, people's lives can be on the line.
Yeah, and that's a really important point. And I think this is part of when I talk to clients and I talk to practitioners, right? We're still divided, right? And in some sense, it comes down to policy, it comes down to ethics around what we're going to use, what we're not going to use. And the whistleblower phenomenon is great, but it's tremendously scary, right?
Yeah.
So when you get impacted, let's say, on a fraud decision, right? And we've been using these models, neural network models, for more than 25 years in Falcon. That's one impact, right? But whether or not you receive the proper health care is a really much bigger impact, right? And it brings me to the topic of the scientists. And last year at FICO World, I shared some of my fears. And one of my fears, I said, was not the Terminator, right? It was the data scientist cowboy, right? These folks that are going to apply algorithms blindly, and they're going to come up with these models, and they're going to show their bosses how much lift they get on a model, and they're going to be superheroes, right? Because that is really what worries me. It worries me in two ways, right? It worries me when data scientists are using models for evil, right? And where they might be using AI in ways that are kind of incorrect, right? And it worries me because sometimes well-intentioned data scientists may not be building models to the proper level of rigor, right? And my general philosophy on this is that we don't understand the very, very big responsibility that we put on data scientists, and our organizations are dependent upon these models, right? And this really turns into a framework in my mind of governance. But I wanted to get your view around that topic because, for me as a chief analytics officer at FICO, I'm generally always meeting very, very bright scientists, and they are always developing these models, but they don't necessarily have the framework around them to protect themselves and protect the company when it comes to the models they build for customers. And what's your thoughts around that?
I have thoughts, but first of all, I want to hear from you. What is an evil purpose? Weren't you curious? Or like, what is it like an evil AI? Because we know it's not the Terminator. We're so far from that right now. But what do you think the most problematic uses are?
So I think the most problematic is either intentionally or unintentionally changing the training data to come up with a desired outcome, right? So when you look at when these models are built, right, if you don't have controls around how that data was constructed and reviews of bias, right? It can sneak in there.
See, I was thinking you were going to say Cambridge Analytica, or you were going to say,
I was going to say that for you.
I'm trying to think who's like the bad guys. Yeah, I mean, it's interesting because I'll tell you a story that happened to me. This was a paper that was written just over a year and a half ago that was trying to predict, using machine learning, if a crime was gang-related. So what the scientists did is that they used LAPD data, what's known as the Cal Gang database. Seems like a good thing to train your model on. And what they did is they said, oh, we've trained this model. Now, if any crime happens, we can tell you if it's gang-related. Just one problem. If you actually look at the Cal Gang database, more than 23% of people in that database have had nothing to do with gangs. They're in there purely by error. And actually, one of my favorite is that there are large numbers of babies in the Cal Gang database as admitted gang members. It's like, got to keep an eye on those guys. Real problems. So what was interesting is when this paper got presented, one of the authors said, Oh, what do you mean there are ethical problems or data quality problems? I'm just an engineer. That was their phrase. I'm just an engineer. And that made me think of what you've been saying about data cowboys. It's this idea that we're training people, if you're working with data, that you don't have to think about issues of quality. You don't have to think about ethics. Why would you think about privacy? You just be an engineer, you do you, and you make sure that you have a model that just works as quickly to come up with the most interesting predictions that it can. That's the end of the story. I think that is a serious problem that we have across the industry, is that we haven't thought more deeply about what are the responsibilities of working with data, of being a data scientist, of being an AI engineer. These are really important jobs that right now are remapping our society. They are making crucial decisions and predictions inside every single social institution that matters right now. Where your kids go to school, what kind of treatment you're going to get in hospital, if you end up in the criminal justice system, whether you'll be approved for bail or not. All of these things are being touched by large-scale machine learning systems. And if the people building them aren't using that level of personal responsibility and sector-wide responsibility, we're in real trouble. I mean, you guys are different because you've actually had regulations. You actually have structures around what you can use and where. But we're talking about fields where you're completely outside of regulatory structure. So if that isn't keeping us up at night, I don't know what is. And that's really why, in my case, I was like, we actually need to create an independent research institute that just looks at these questions and actually forensically studies these systems to see where these problems are happening before they occur.
Absolutely. And for me, I've been driving this sort of philosophy around what we call a blockchain model development process, right? And so it even gets a bit further than that. We've always had very deep processes around how we build models, who we assign, what the data looks like, what are the success criteria, what are the requirements for these models, and then to march through it. But now it's gotten to a point where when I talk to many of our customers, right, 80 to 90% of all the models they build, they don't deploy because they couldn't pass governance, because they can't ask those fundamental questions. And so, this is really around a framework, and it's much more like a software development framework around the development of these models, but it's primarily to capture, is it developed properly? Who's developed these models? Have we demonstrated that we're supposed to, meet those requirements? Have we diced out where there could be bias? Have we tested for that bias? And then essentially have that checked all the way along the way. And if we're not doing those things systematically, then they're either not done at all, or they're slipping through the cracks. And that's a really, really big challenge for our industry.
So I want to ask you a hard question, because this is a closed room, and we can talk about sort of the real issues that are happening right now. I want to ask you, how would you know? How would you know if that's been collected well, if that data is representative, if the person has done it for this use and not for another? How are you even tracking that?
Yeah, so I think this comes down to the focus on what is that data set that we're using, how was it built, working with the business around what those requirements look like, and then focusing specifically on the features, the variables, and the latent features. That's why I'm so focused on these sort of explainable machine learning architectures from first principles. So if it's explainable and interpretable first, I'm not going to have to guess, or hopefully my test suite of tests will dice out where the bias exists. And so that's one of our processes today, is to really move away from things that are not interpretable, even for our own development, right? So that we can make sure that we're not making those mistakes, inadvertently as we develop those models. I
mean, what I love about this conversation is that we're really kind of doing the real talk about what it's like when you actually build these systems. And it can look extremely polished from the outside, but when you really are actually on the inside, you see how these questions are make or break in terms of whether or not that system is going to be good in the long term or even the short term. I mean, it's one of the things that I was really sort of inspired to do a couple of years ago with a group of my colleagues, where we said, look, if you want to use a training set on the internet right now, do you know how you do it? You download it. It's really hard. You don't have to ask anyone's permission. You just download it, and then you can build a model on that. Okay, that sounds great. That sounds like democratizing AI. However, what if you're using that data set in a way that it was never intended to be used? Or what if you have no idea what's really in that data set, or what its demographic breakdown is, or where it was gathered, and maybe that location really makes a difference? So one of the things we created was this idea called data sheets for data sets. So if you're making hardware, like if you're making an iPhone, every single one of those components, from the camera to the components on the inside, we have data sheets that say, okay, this does not function above 200 degrees centigrade. This shouldn't get wet. These are all of the terms that you need to know for hardware. We needed the same for training data. And so that's what we created. It was basically these sheets that append to every single data set so that you can say, oh, okay, so this is where it was gathered. Here's who gathered it. Here's why they gathered it. Here's what's in there. Here are some privacy issues you should be aware of. Here are any other legal or ethical concerns we might have. And that means that every time you work with the data, guess what? You've got the equivalent of something like a nutrition label that you can see, this is what's on the inside and this is what it might do to you, right? But it was crazy to me that we were creating this and that it didn't already exist, and that these training sets have been used for decades without anything as simple as a label on the box to tell you what's in it.
Yeah, that's super important, and we see the roles of chief data officers and chief analytics officers, right? But those two roles actually have to coexist really, really closely. What's permissible use? What's the provenance? Right, where did it come from? What can I use it for or not use it for? And without that, right, it's very difficult to address the bias question or even the ethics question, because you're not in control of that data and how it was sourced. Kate, I want to thank you. It's been great. I think it's been a really good conversation, and thank you again for your time.
It's been a pleasure, Scott. Thank you so much.
Thank you.
Cheers.